Charlie Munger said it in 1994 at a Berkshire Hathaway shareholder meeting, and it has been repeated so many times since that it has started to feel like motivational poster content rather than what it actually is, which is one of the most precise and testable observations ever made about how personal wealth accumulates. He said, "The first $100,000 is a bitch." He used that word specifically, which was notable for a man known for careful speech, because he was trying to communicate something about the difficulty that softer language would not have conveyed accurately. He followed it by saying that you have to do it however you can, that after that you can ease off the gas a little, and that compounding takes over from there. Most people who have heard this quote have understood it as encouragement, a famous billionaire acknowledging that early wealth building is hard. What they have not done, in most cases, is run the mathematics of why it is hard. Why specifically $100,000 is the inflection point Munger chose, what changes on the other side of that number, and what the compounding dynamic looks like for the person who reaches it versus the person who gets stuck below it for a decade. Because the math of the first $100,000 is not motivational. It is mechanical. It is a description of how compound interest works before and after a specific threshold. And the mechanical description changes how every month of saving feels during the years before you reach the number, which is the period when most people make the decisions that determine whether they ever reach it at all. Start with the most concrete version of the problem. A 25-year-old woman named Olivia earns $58,000. She has nothing saved. She contributes 15% of her gross income to investments, $8,700 per year, $725 per month, in a low-cost index fund that returns 8% annually. In her first year of saving, she contributes $8,700. Her investment return at 8% on an average balance of approximately $4,350, the rough midpoint of her balance across the year as contributions accumulate, is approximately $348. In year one, Olivia's own contributions account for $8,700 of her balance growth. The market's contribution to her wealth is $348. She did $96 of work for every $4 the market did. The ratio is 24-1 in favor of her own effort over the market's compounding. This is the correct ratio for year one of a savings journey, and it is the ratio that makes year one feel like what it is, a period in which wealth building is almost entirely a function of your own behavior, your own sacrifice, your own willingness to save money that could have been spent, with almost no assistance from the mathematical force that will eventually do most of the heavy lifting. Now follow Olivia forward to the moment the ratio begins to change. By the end of year 4, at consistent $725 monthly contributions and 8% annual return, Olivia's portfolio has grown to approximately $42,000. Her annual investment return at 8% on a $42,000 balance is approximately $3,360. She is still contributing $8,700 per year. The ratio is now approximately 2.6 to 1. Her contributions still dominate, but the market's annual contribution has grown from $348 to $3,360, a tenfold increase over 4 years, not because her salary changed or her savings rate changed, but because the base on which compounding operates has grown large enough to produce a meaningful annual dollar amount. The compounding is accelerating, the ratio is shifting, but Olivia is still, unambiguously, doing most of the work. By the end of year 9, Olivia's portfolio has grown to approximately $107,000, just past the $100,000 threshold. Her annual investment return at 8% on $107,000 is approximately $8,560. She is still contributing $8,700 per year. For the first time, her annual investment return is approximately equal to her annual contribution. The ratio is now roughly 1 to 1. For every dollar Olivia saves from her paycheck, the market generates approximately $1 on her behalf. She is no longer doing 24 times the work. She is doing the same amount of work as the market. She has crossed the threshold that Munger identified, and the sensation of crossing it, when you follow Olivia's monthly portfolio statements through the years that precede it, is the sensation of a slope becoming level after a 9-year climb. Not dramatic, not sudden, but mechanically, compoundingly, permanently different from what it was before. From this point forward, from the moment Olivia's portfolio exceeds $100,000 and her annual return exceeds her annual contribution, the compounding begins to do progressively more of the work than she does. At $200,000, her annual return is $16,000. Her contribution is $8,700. The market contributes nearly twice what she contributes. At $300,000, her annual return is $24,000, nearly 3 times her annual contribution. At $500,000, her annual return is $40,000, 4.5 times what she saves from her salary. By the time Olivia reaches $1 million, her annual investment return is $80,000, 9 times her annual contribution. She is still saving. The compounding no longer needs her savings to produce meaningful wealth growth. The money has begun to make itself at a rate that her behavior, however disciplined, cannot match, and could not have accelerated significantly even if she had saved twice as much in year 1. This is the mechanical reality behind Munger's observation. The first $100,000 is the hardest, not because building it requires more skill or more sacrifice than building the next $100,000. The contribution rate is the same, the investment choices are the same, the market returns are the same. It is harder because the ratio between your effort and the market's contribution is most unfavorable at the beginning, when nothing you have done has yet accumulated a base large enough for compound interest to become your coworker, rather than a distant acquaintance who sends you a card once a year. The grind of the early years is specifically, structurally, the grind of building the compounding base. The period during which you are doing 24 times the work the market is doing on your behalf, saving money that could have been spent, watching a balance grow at a pace that does not feel proportional to the sacrifice involved. In a period of life when the alternative deployments of that money, experiences, travel, consumption, the visible signals of living fully, are most available and most socially reinforced. The early years are hard for exactly the reasons they feel hard. The math confirms the feeling, and the math also tells you something the feeling cannot, that the hardness is temporary in a specific and calculable way, that the ratio changes, that the slope levels, and that the person who reaches the threshold experiences a permanent shift in the relationship between their effort and their wealth that the person who stops below it never encounters. The corollary to Munger's observation is equally important and equally underdiscussed. The first $100,000 is not only the hardest to build, it is also the most expensive to delay. Every year that the $100,000 milestone is pushed back is a year in which the investor-to-compounding ratio remains unfavorable, a year in which the annual return on the portfolio is lower than it would have been 1 year further along, and a year in which the threshold from which the compounding accelerates is further from the investor's current position. The delay cost is not linear, it is exponential, and it operates specifically during the period when delay feels most justifiable, when income is lowest, when expenses are highest, when the competing uses of each marginal dollar are most numerous and most present. Meet a man named Thomas, who is also 25 and also earns $58,000. Thomas makes one decision differently from Olivia. He waits 3 years to start. Not out of irresponsibility, out of the specific combination of student loan repayment, rent increases in his city, and the genuine difficulty of funding a meaningful savings rate while establishing himself in his early career. By the time Thomas starts saving at the same 15% rate at age 28, Olivia has 3 years of contributions behind her and approximately $28,000 in her portfolio. Thomas begins at 0. His year 1 experience is identical to Olivia's year 1 experience. The ratio is 24 to 1. The work is his. The compounding is negligible. He reaches $100,000 at approximately age 37. Not 34 as Olivia does, but not dramatically later. The 3-year delay produced a 3-year delay in reaching the threshold. From this point forward, Thomas and Olivia are on the same trajectory, the same ratio improvement, the same compounding acceleration, the same relationship between contribution and return. The compounding does not punish Thomas for the 3-year delay in perpetuity. But the 3-year delay in reaching the threshold means 3 fewer years during which Olivia's portfolio was compounding above $100,000 and Thomas's was not. By the time both reach age 65, Olivia's portfolio has grown to approximately $2,617,000. Thomas's portfolio has grown to approximately $2,076,000. The 3-year delay cost Thomas approximately $541,000 in terminal wealth. Not from lower contributions, not from worse investment choices, but from 3 years during which the compounding base was below the threshold, and from the 40 years during which the $28,000 gap in starting balance at age 28 compounded forward at 8% annually to produce a $541,000 difference in the account that Thomas will spend his retirement from. The most expensive thing Thomas did was wait for a better time to start. The better time cost him $541,000. The time he waited in was the better time. The second corollary, the one that changes how saving decisions feel during the early years, is about the specific dollar value of each early contribution compared to each late contribution. This calculation is the one most financial planning conversations omit, and that most consistently changes behavior when people see it. At 8% compounding over 40 years, every $1 saved at age 25 is worth approximately $21.72 at age 65. Every $1 saved at age 35 is worth approximately $10.06 at age 65. Every $1 saved at age 45 is worth approximately $4.66 at age 65. The dollar saved at 25 is worth 4.7 times the dollar saved at 45. Not because it was saved more wisely, not because a different investment was chosen, but because it had 20 additional years on the compounding base. The $100 monthly contribution Olivia makes at 26 is not worth $100 to her retirement. It is worth $2,172. The $100 monthly contribution she makes at 36 is worth $1,006. The specific implication of this calculation is that the most valuable saving decision you will ever make is the next one, the contribution scheduled for next month, at whatever age you currently are, because it is the contribution that will compound the longest and therefore produce the largest terminal value of any contribution you have not yet made. The most expensive saving decision is the one you postpone, because the compounded value of the postponed contribution decreases with every month of delay, not in a way that is visible in the moment of postponement, but in a way that is precisely calculable from the moment it occurs. The behavioral environment of the early saving years, the specific psychological experience of building toward $100,000 from zero, is the part of the wealth-building journey that most personal finance content describes inadequately. The content describes the mechanics correctly. Save early, invest consistently, let compounding do its work. It describes the end point correctly, the portfolio that funds a comfortable retirement, the financial independence that the compounded decades produce. What it describes inadequately, and what produces the attrition that causes most people to stop, pause, or significantly reduce contributions during the early years, is the specific experience of the journey between the beginning and the threshold. The experience is characterized by 4 specific features that the mechanics do not capture. The first feature is the invisibility of progress. In the early years, the portfolio grows slowly relative to what it will eventually grow at. From $0 to $10,000 feels like a long time. from $10,000 to $20,000 feels like a long time. The doubling that happens at smaller balances, from $50,000 to $100,000, feels slower than the doubling that happens at larger balances, because the same 8% annual return on $50,000 produces $4,000 per year, while 8% on $200,000 produces $16,000 per year. The investor who is watching the balance grow in years 2 through 5 is watching it grow at the rate that produces the largest terminal value, not the rate that feels most satisfying in the present. The progress is happening. The progress does not feel like progress at the rate the investor hoped for. The second feature is the full competition from present consumption. In your late 20s and early 30s, essentially every dollar not saved is a dollar that can fund a tangible, immediate, visible experience. Travel, dining, upgraded housing, the accumulation of the material signals of an adult life that looks like the life you imagined when you were younger. The alternatives to saving are not abstract in the early years. They are specific and available and socially reinforced by the behavior of the peer group that is visible to you. The investor who saves $725 per month at 27 is making a choice against a set of alternatives whose appeal is maximum at exactly the age when the compounding case for saving is also maximum. The difficulty is not a feature of weak character. It is a feature of the specific collision between the early-year compounding imperative and the early-year consumption opportunity that cannot be resolved without the mathematical understanding that makes the $725 monthly contribution feel worth the full $15,742 it will actually contribute to the retirement portfolio, rather than the $725 it costs today. The third feature is the absence of social proof. The investor who reaches $100,000 at 34 does not announce it. The investor who reaches $500,000 at 42 does not discuss it. The investor who retires at 55 with $1.8 million and a paid-off house is, to most of their peer group, simply a person who seems to have made reasonable life choices without any visible evidence of the specific discipline those choices required across 25 years of consistent saving during the period when everyone else was spending. Financial success in the accumulation phase is largely invisible, which means the investors building it have almost no social reinforcement for the behavior that produces it, and are surrounded by highly visible social reinforcement for the competing behavior: consumption, experience, the signals of living fully now, that the financial success required them to moderate. The invisibility of the savings behavior means the person practicing it is, in most social contexts, doing it essentially alone, reinforced only by the number in the account statement, and by whatever conviction they have in the mathematical argument for why that number matters more than the experiences it was not spent on. The fourth feature is the compounding gap between saving enough and saving optimally. The investor who saves 5% of their income during the early years is not 10 percentage points behind the investor who saves 15%. They are the full compounding difference behind, not just the contribution gap, but the compounded value of the contribution gap across the 40 years the contributions will grow. The 5% saver and the 15% saver both experience the difficulty of the early years. Only one of them reaches the threshold at 34. Only one of them begins experiencing the ratio shift at that age. The other reaches it later, or not at all. And the terminal wealth difference between their two paths is not proportional to the contribution difference. It is amplified by the compounding that operated on one balance and not the other for the years the threshold was not reached. The $100,000 question that most people in their late 20s and early 30s are not asking, but that the math of compounding makes the most important financial question of that specific life period, is not how to invest or what to invest in. The fund selection, the asset allocation, the specific account structure, these are real considerations with real consequences, but they are second-order questions relative to the first-order question, which is simply, What is my current trajectory to $100,000? And what can I do in the next 12 months to accelerate it? Because the specific lever that most influences the answer to that question during the early years, when contributions dominate and compounding is minimal, is the savings rate. The asset allocation matters. The savings rate matters more, by a factor that grows larger the earlier in the accumulation phase the question is being asked. A 10% improvement in the savings rate during the early years produces a compounding benefit that no asset allocation decision available in a diversified low-cost portfolio can match. The investor who increases their savings rate from 10% to 15% of gross income at 27 has made the highest return financial decision available to them in that specific moment. Higher return than any specific fund, any timing decision, any strategy discussion about optimal portfolio construction. The conversation that most financial planning content has is about what to invest in. The conversation that most changes the outcome of the early years is about how much. The $100,000 milestone is worth celebrating not because it is a round number or because it has social significance, but because it is the specific mathematical threshold at which the investor-to-compounding ratio crosses 1-to-1, and from which the investor begins to receive a return on the years of discipline that precede it that is finally proportional to the investment those years required. Olivia will cross that threshold at approximately 34. She does not know this yet. She knows she has $23,000 after 3 years of consistent contributions, and that the growth rate feels slow relative to the sacrifice the savings rate requires, and relative to what she imagined she would feel when she started. What she cannot see from her current position, with $23,000 in the account and 11 years between her and the threshold she has not yet identified as the threshold, is that the period she is currently in is the one Munger was describing, and that the difficulty she is experiencing is the precise mechanical difficulty of building a compounding base from zero, and that the base she is building has a specific, calculable dollar value that is not the $23,000 on her statement, but the $23,000 multiplied by the compounding factor for the remaining years of her investment horizon, which at 8% for 40 years is 21.7, which makes the $23,000 she has already accumulated worth approximately $499,100 in terminal wealth at 65, a number that exists in her future with the same certainty that the compound interest formula has operated in every 30-year period in the history of equity markets, waiting for her to reach the threshold, waiting for the ratio to shift, waiting for the 9-year mark when the market begins contributing approximately what she contributes, and then more, and then significantly more, and then most of the work, and then effectively all of it, if she keeps going, which is the only condition the mathematics requires, and which is the condition that the difficulty of the early years makes harder than it should be for the person who is living through it, without being able to see what is waiting on the other.